Hi, my name's Gabriel Londres, and this is the third project of the Design and Manufacturing class. So, my first topic that I'm going to be discussing is milling. Um, Summary of milling. Milling uses a rotating tool to remove material from a build or a part, which can create holes, shapes, slots, and contours in a workpiece. Different types of milling. Face milling is for flat surfaces. End milling is for pockets and or contours. Slot milling is for grooves, and profile milling for edges. So different tooling for a mill are end mills, face mills, slot drills, and these are usually made from materials like carbide, and they will be chosen depending on the task and the type of material you are milling. So the main parameters for milling is feed rate, spindle speed, depth of cut, and step over control efficiency, precision, and finish. And then there are many different milling types, ranges from 3-axis to 5-axis, which enables very complex cuts. So why is it important? It is very versatile, can create complex shapes, contours, and a variety of surface finishes. It works with many different metals, plastics, and composites. Um, it is very high precision, allowing for tight tolerances, which is very critical for tight tolerance industries. Um, it is very efficient. Modern CNC milling is automated, which speeds up production incredibly, and it is very customizable. It's good for small batches and also mass production with flexible tool setups for different part designs. And it is also very cost effective as there is not much waste and it's very repeatable. So, a couple capabilities and limitations. So, it's very precise, it can create very complex shapes. There is a wide material compatibility and it's very customizable, as I said before. And a couple limitations is that the tool wear is quite high. The material waste can be high depending on what kind of milling you're doing, and it can be kind of challenging on soft materials. And then the setup time can increase time and cost for smaller part runs. So the next method of manufacturing is sheet bending that I'm covering. So sheet bending uses force to deform sheet metal along a straight axis, creating curves, angles, or shapes. So common techniques include press braking, roll bending, and air bending. So usually press brakes and rollers, which apply precise controlled force, are used. And then some material factors are thickness, ductility, and a type of material. And then this sheet bending is used in automotive, aerospace, and construction for frames, enclosures, and structural components. So why is it important? Again, it is very versatile. The material efficiency is high as it minimizes waste incredibly, um, without cutting away any material. Um, Bends add rigidity to thin sheets, which increases structural strength, and it's very cost effective. It produces parts quickly and efficiently and in high volume, and design flexibility supports both custom and standard parts designs across many industries like electronics and appliances. So a couple capabilities and limitations. Um, so capabilities, precision, range of geometries produce many different curves and V-shaped profiles. It's very flexible, works with many materials of various thicknesses and types. And these sheet bending can also be done with CNC controlled presses, which provide consistent and repeatable bends. So a couple limitations are material cracking, spring back, limited complexity, and tooling costs. So for cracking, some metals are prone to cracking if bent beyond their ductility. Spring back is a phenomenon that metals naturally spring back after bending, which requires compensation, and more intricate shapes may require additional forming or assembly steps. So SLS printing, this is selective laser sintering. Uses a laser to fuse powdered material layer by layer to create 3D parts. So common materials include nylon, polyamides, and a couple of metal powders. A couple advantages are that it's very high precision, and there's not any need for support structures due to the powder bed. So this is very good for prototyping and end-use parts in automotive, aerospace, and medical industries, and it requires a controlled environment and very high-powered laser for material fusing. So why is this important? Prototyping is very important as it allows for fast production of complex plastic or metal prototypes without any tooling. It can achieve very high detail and intricate designs and incredible dimensional accuracy. And it's very versatile, well with a range of materials, supporting functional prototyping and small batch production. So a couple capabilities and limitations. Capabilities, it can produce very complex geometry, which is ideal, like I said, for intricate shapes, and it's good for internal channels, has good mechanical properties, it produces strong functional parts with a nice surface finish. A couple limitations of SLS printing is that the surface can be porous at times. Some materials may have slight porosity, and post-processing may be required. And in terms of speed, it is not as fast as other additive manufacturing processes, depending on the part that you're making. And it's primarily limited to thermoplastic and a couple metal powders. So lens printing is another type of additive manufacturing. Um, this is laser engineered net shaping. It uses a high-powered laser to melt metal powder, which is deposited directly onto a build surface. So materials used pretty much all metal, includes titanium, stainless steel, Inconel, molybdenum. A couple key advantages. It's very good for creating complex metal parts and repairing worn or damaged components. Um, a couple applications for this can be aerospace, again, medical implants, and industrial part repairs. Um, The these lens printers often require very high-powered lasers, controlled power delivery via argon gas, and often operate in a sealed chamber with inert gas, such as argon. Why is it important? It is capable of creating very strong functional metal parts. It's very nice to use for adding material to repair high-value parts, such as turbine blades, and it supports production of custom metal components, ideal for industries with specialized needs, and it's very useful for research, which is something actually that I do, which you are able to print mixed powders to research new composite materials. So a couple capabilities and limitations of this. Metal part repair, it's very effective for adding material or to repair or reinforce existing metal components. Parts have strong mechanical properties and excellent durability, depending on the material chosen. A couple of limitations of this, the surface finish is rough sometimes, so it may require post-processing for a smooth finish. And powder handling requires very careful handling and a controlled environment due to the metal powder being extremely fine and easily inhalable. Um, so the last topic to cover is FDM printing. So FDM printing is fused deposition modeling. This melts thermoplastic filament, extruding it layer by layer to build 3D parts, such as um, prototypes and things like that, like the other two topics. Common materials include PLA, ABS, PETG, and nylon. A couple options from composite and flexible materials. A couple materials also have carbon fiber um, bits in it to reinforce it. Key advantages, very cost effective, extremely easy to use, and compatible with a large range of thermoplastics. A couple applications are prototyping, educational models, functional parts for low stress applications, um, and it requires a heated print bed, extruder, and usually works at atmospheric conditions depending on which type of material you are printing. Why is it important? They're widely available from desktop models to industrial systems. They're very cost effective due to this, um, and they provide rapid prototyping in a large material variety. And a couple capabilities and limitations. So it can create complex geometry, and it is very scalable, and it's extremely easy to use, very simple setup and operation. It's very suitable for a wider user base. And a couple limitations for this, the surface finish can be poor at times depending on your parameters. Some visible layer lines and rougher surfaces can be seen. Part strength can be lower along layer lines, and often support structures are required for overhangs. That is all.